Okay, this is our access control lab that we have opened up here. You'll notice back in Brightspace here, you've got two options to choose from for your access control list lab. You got ACL.packet and ACL's base.packet. If you choose the base packet, that has included all the basic network configurations we already have done. If you want more practice, you go through and do the full thing with the just ACLs.packet. So this one's the base. So we already have our connections are up and running, our routing's up and running, router on a stick between VLANs is up, our DHCP server is configured, everything's ready to go. Right now, this device can talk to any device on the network, vice versa with anything else. But what we want to do is change that. So we need to configure some access control list, which we can use to limit traffic so that we can make it so that only PCs and laptops in the same broadcast domain can communicate. So right here they can communicate, PCs and laptops right here can communicate, and PCs and laptops right here can communicate. But we also need to make sure that PCs can only communicate with PC VLANs outside of their broadcast domain. So PCs outside of this broadcast domain should only be able to talk to the PC VLAN here and the PC VLAN here, and vice versa. Laptops should only be able to communicate with other laptop VLANs outside of their broadcast domain. So while the PCs and laptops can talk in this domain, laptops should only be able to talk to laptops here and laptops here. Now, how can we filter our traffic? We have to use what's called access control lists. And what access control lists are, they are a list of rules that you will apply on a router's interface that can permit or deny traffic in or out of that interface. So let's let's hop into this router here. Let's move off to the side so you can kind of see everything. So let's hop into the CLI. We're going to enable conft. So you use access lists from the global configuration. So if we scroll up here after doing that question mark, we'll see access lists. Add an access list entry. All right, so let's type in access list and hit question mark here. So you get two options, and we'll talk about both these. So 1 through 99 is a standard access list. 100 through 199 is an extended access list. So you declare what kind of access list you're creating by giving a number right after access list here. And like we've done with VLANs and sub interfaces all throughout the year, you want to name your access list something that helps you relate to the traffic you're trying to permit or deny. In this case, we want to stop this PC here, PC VLAN 10, from getting to talk to the laptop VLAN here. So we're going to call it access list 10. And and that's because we want to do a standard access list. If I want to do an extended access list, it has to be higher than 100, so I might name it 110 to help me remember what it's for. But we're going to do a standard one here, just as a demonstration. We do access list 10. Let's put a space bar in a question mark. So the next options we get here, we can deny, permit, or add a comment. But the only things we need to care about is deny and permit. Now that's pretty self-explanatory here. If you put a deny right there, you're going to specify what kind of traffic you want to deny from having access. If you're going to put a permit, then you're going to put what kind of traffic you want to permit to go through this port. So here we want to deny this PC VLAN from coming through the router and talking to our laptop. So we're going to choose deny. Put space and another question mark here. So see, now it wants to know what address to match. So you have the option, you could put, they show the ABCD, that's your IPv4 4 octets there. You could pick a network. You can choose any, so literally any traffic at all, or a single host, a single IP address. But we're going to choose a network here because we want to choose this PC VLAN that we're going to block. So we're going to do 192.168.10.0 space, and let's put another question mark in here, what they want. So it wants a wildcard mask right now. So a wildcard, think of it as kind of the opposite of what a subnet mask is, where the zeros indicate numbers that you want to exactly match, and putting in a 255 means anything. Let's type in what our wildcard would be here first, and I'll explain it. So you can see our wildcard, if we were doing a, your usual 192.168.10 network, your subnet mask would usually be 255.255.255.0. We can kind of flip that and think of, the zeros mean match this. So when we're saying match this, we're saying deny traffic from 192.168.10.0, but specifically match 0. So match that first octet, 192, match the second octet, 168, match that third octet, .10, but anything else in that last octet. So 192.168.10 has to match, but then dot anything, .1, .50, .120, that specifies anything, and hit enter. So with this access right here, we are saying deny traffic from the PC VLAN 10, and we're going to apply it on the interface that goes to the laptops to block access. But we don't just want to stop one PC group from talking to this laptop group. We want to stop the second one too. So we're going to do that again. You can hit up and just edit your commands, change them for the PC VLAN 30. But let's type it back up. So we're going to go access list, the same access list here, because this is where the list part of it comes in. You're going to list off filter after filter going through your access list. So we do access list 10. We're going to deny, because we're denying another set of traffic here. But this time it's not going to be the 10 dot address, it's going to be the .30 address. We're going to deny 192.168.30. Got a typo there, 168.30.0. So once again, now we're going to need to put in our wildcard here is what they want. And again, your wildcard, you're putting in zeros designate match this part, and 255 designates anything. So we want to match the 192, we want to match the 168, we want to match the 30, but we want anything on that 30 network, so we're going to put 255. So right now in this access list 10, we have two commands. We're going to deny VLAN 10, this 192.168.10. We're going to deny 30, 192.168.30. But the thing with access lists is, as you create them, you have what's called an implicit deny at the bottom. So if you don't explicitly tell an access list, permit or deny this traffic, as it's reading through your access list, comparing the traffic, if it doesn't hit something that matches, it's just going to drop it. It gets that implicit deny all. So let's do a show run here. Do show run because we're not at the executive privilege mode. There we go, and let's space down until we get our access list here. So here it's showing what our access lists are. So as we apply this to an interface, what the router is going to do is going to check the traffic against our access list. And it's going to do this in sequential order. It's going to start with this top one and drop down to the next one. And if the traffic coming through doesn't match either a deny or a permit statement, it has that implicit deny, it's going to just drop it from the router. So traffic coming in from this PC VLAN 10, the router is going to see that. It's going to look at this and be like, hey, I've got a deny here. Do you match this statement? 192.168.10.0, anything? Yep, you match that, I'm dropping it. If traffic comes from this PC VLAN up, down, through, it's going to first compare it to that first one there and say, do you match this? Nope, you're not .30, I don't care. Let's go down to the second one and say, oh, you are .30, dropped. But the problem with our access list right now is we have to specify what we want to allow. Otherwise, that implicit deny is going to drop all the traffic. Right now, if we get traffic from this laptop VLAN here, which we want to go to this laptop, other laptop VLAN, the 192.168.20 network, since we haven't mentioned it in our access list as either permitted or denied, the router is going to look at it and be like, okay, do you match this first statement? No. Do you match the second statement? No. I don't have you matching any statement. My implicit deny says block this traffic. So we need to go back in, do access list 10, and there's no, I should preface here, there's no right or wrong way necessarily to write how you're going to permit and deny your traffic to decide how you're going to write up your access control list. You could go through here and specifically only permit then next these two laptops groups. Well, that could cause issues. What if for some reason this router has to talk to your laptop? Or you add another network segment, then you have to go back in and re-edit your access list. The other option you can have, instead of going through and permitting network after network, you can use the any command. So we do access list 10 permit any. And that's going to allow any traffic that doesn't match those first two lists that we created. It's going to say anything. So let's do a do show run again. And let's look at this access list. So now our access list, and remember, it always processes it from top to bottom first in sequential order. So if we get this traffic from the laptop VLAN here, it's going to say, are you this one? Nope, you don't match that. Go on to the next one. Nope, you don't match that. Do you match anything? Yes, permit. And that's how you get past the implicit denial, just dropping all your network traffic. So that first step is creating your access list. But just having an access list doesn't do anything for you unless you apply it. So we already got our show run up here. Let's look at if we did our sub interfaces correctly so the naming conventions make sense. We should have a sub interface for VLAN 50 and a sub interface for VLAN 60, numbered 50 and 60. And we do right there, 50 and 60. So we need to apply this, this access control list to the sub interface that handles the laptop VLAN. So it's going to be 60 because that's the trap we created, blocking PC traffic going to our laptop. So let's hop into that sub interface here. So it's interface gigabit 0/1.60. So here's where the command to apply an access list is IP access group. It's a question mark there. They want the number of the access list you're applying. Let's do question mark again. And they want to know if it's inbound or outbound traffic you were filtering on. Now, this could be kind of tricky. I think it's best to think of it as how is the traffic flowing inside the router right now? Is it already in the router trying to leave an interface, or is it on a network segment somewhere trying to get in? So as we're putting it on the sub interface, which is right here on the router, traffic coming from here, it's going to be coming from the PC through these routers. It's already going to be in the router and trying to leave to go down to this interface, so it's going to be out. There we go. So let's give this a test here. All right, so let's test it out here. So this PC should not be able to ping laptop 3 over here. And they all should have, we do an IP config 10.2. They all should be getting the first IP in the subnet. So this should be 20.2, 30.2, 40.2, 50.2, 60.2 for that last laptop group there. So let's try pinging that one here. Destination host unreachable. There we go. But let's try pinging the PC VLAN here. See if that works out. This first one here should be an ARP. Will fail. And the next one should go through. There we go. All right, that is standard access control list. So, thing with standard access control lists, you always want to apply them closest towards the destination that you want to block from. So we want to block traffic from this PC VLAN from getting to this laptop, and that would be the closest interface on a router to this laptop group. Same thing with this. We want to block this PC group from reaching that router. This is the closest interface available. So that's where you want to apply it. And it's the opposite with extended access control lists, and we'll cover those in the next video.